So here we have several histograms. What do histograms have to do with means and measures of central tendency? Well, let's take a look. This histogram shows the SAT scores of a group of students randomly selected from the USA. The mean score is 1,500 combined. Because there's 3 parts, the mean score on each is 500. It is also the most common score. The biggest chunk of students score right near the middle. This histogram is what we call symmetric. The mean, median, and mode are all the same. Mean, median, and mode are all right down the middle. SAT scores have a symmetric distribution with most students scoring close to average. Why? Because the test was designed to do that. My tests usually don't have a symmetric distribution because that's not how I design them. So this one is about the ages of students in this college. There is a large chunk of people in their late teens or 20s, but we also have quite a few people who are older than that but still attending college. This is a tail. This distribution, this shape, is right skewed. It has a long tail going off to the right. And maybe the median is about here, but the mean might be further to the right. It's not symmetric, so the mean and the median are no longer on top of one another. The median score would find the age of a typical student at Essex County College. The mean score is mean age is if you add up all of them and divide by the number of people in the college. This is an approximate histogram of the ages at which people in America die. Very few people, in fact, I think I didn't make it dramatic enough. Very few people die in childhood or early adulthood. Most people die somewhere between the ages of 50 and 100. Age at death is left skewed. Most people get old and then die. I do not want to ever live in a country where age at death is right skewed. No, 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 no. That would be bad. So the mean, also known as the life expectancy, will be to the left of the median, because it is left skewed. Now this last histogram is about what would happen if I took a regular six-sided die. Remember, die is what you call one of them if you have dice, and you roll it over and over again and you record what happens. I get 1s, 2s, 3s, 4s, 5s, and 6s approximately equally often. This distribution is called uniform. Uniform means everybody is the same. A uniform distribution is the same height all across. In fact, the uniform distribution does not show up very often in nature. This shape here, this symmetric shape, is a lot more common. So, these are some different shapes that histograms could take on. With real data, they might not be quite this neat, but you should still recognize the pattern when you look at a histogram of whether it's symmetric, right skewed, left skewed, uniform, or possibly doing something else crazy, maybe like this. That's symmetric, but that's a really weird symmetric. I don't even know what kind of data set would do that. This is weird. So, these are histogram shapes and what it tells you about the median and the mean. When they're the same, it's symmetric. When they're separate, that tells you you have a skew.